This is my final presentation for CS6460, and today I'm going to talk about three things. Firstly, I'm going to talk about the paper that I've written at a very high level. Secondly, I'm going to give you a demo of how you can run some of the code that is in the repository which I have provided. And lastly, some discussions around related projects, next steps, and considerations from this particular project. So firstly, what is the problem I'm trying to solve? As you can tell from the title, duplicate question detection using online learning. The whole goal of this is to aim to reduce clutter that using online learning techniques which will adapt based on context. So background to this problem is that oftentimes if we go on Piazza or say Google+, there are a lot of what I would consider to be low value discussion threads. And this is because that there are a lot of threads where the question has already been answered before. This might be in the form of, in Piazza's case, it was a question about an assignment where the question was asked when the assignment was released, and all of a sudden, because and now that thread has just been buried, because all of a sudden you have a bunch of questions which were exactly the same towards when the assignment is actually due. In the case for social media on Google+, this often occurs around registration time or when there are a lot of new students coming on board. That is the scenario when you would have a lot of questions which have been already answered in, say, the FAQs that are provided on Google+, or FAQs that can be easily searched on Google. That is what my paper is trying to address. And it does this through online learning, which I already mentioned, aims to adapt based on context. So the key framework of the problem, or how I tried to tackle it, consists of three parts. And the three parts are, firstly, we want to build text features. Secondly, we want to use matrix cosine similarity to convert those text features, which can then be used in the framework of a normal supervised machine learning type problem. In a text feature building stage, you can read the paper in order to find out more details, but how it works is it uses online learning in order to produce features related to online word-to-vec models, online latent Dirichlet allocation models, and online latent semantic indexing models. So those are the three key online algorithms which are used. In terms of the model selection, I went with the out-of-the-box random forest. I did try a few other models, but I'll talk about that later on in this presentation. So on to the second part, showing you guys a very quick demo of how it works. In terms of what other data sets I've used two main ones. Firstly, I use Reddit, and secondly, I use Stack Overflow or Stack Exchange data. The reason for these two sources is because this is a one-man project, and those two sources had very nice APIs. Other than that, there is really no reason why I use those two data sources. If you click on my repository, you'll notice that there is no data sets, and that's because these data sets are very, very big. Instead, if you click on the respective folders, so that's for Stack Exchange and that's for Reddit, there will be code that will allow you to run and generate the particular datasets that you might be interested in. Now onto the demo. So in this demo, essentially what I do is I build and learn the three models that I talked about, and then it will go and feed it into an and then you'll go and feed it into a supervised learning problem. So this is a somewhat simplified version of the code that I use to run the paper. It's important to note that I am only using a small sample of data because otherwise it would take far too long to actually run the whole thing from top to bottom. So in fact, I only used 25 observations. And you will find one of the advantages of this approach is even with a low observation count, you can get a reasonable model. And that's because when you generate text features, it generally goes very, very wide, very quickly. Because off a single body of text, you can generate a fair number of relatively useful text features. How this code works at a high level is it builds the 3 models, and then it will adapt those models according to these data sets, and then finally it will train the model. And in this case, you can see that the recall is at 0.7, which is reasonably good. Recall can only go from 0 to 1, and the closer to 1 it is, the better. And lastly, we can see the feature importance. And in this case, for Stack Overflow data, which is what this is, generally we see that the latent zero-reach allocation features are the more important ones. If we go to our paper, and you'll find that it's actually different for the Reddit data. The Reddit data, you'll find that the latent semantic indexing is actually the most important one, followed by the latent zero-reach allocation. And I think that's fairly interesting. So what are some of the discussion points that are important? And as I mentioned, maybe you might think, oh, you can improve this model through changing a different type of supervised learning algorithms. And you probably could. So here I've shown that if you use the logistic regression type model, generally there's a degradation in performance. And I believe that this is probably due to some kind of interactions between these sets of features. And personally, when I looked at these numbers, I was reasonably confident that the model was fairly performant. So then when I tried to approach this project to take it to the next level, which of course is building, say, a bot to automatically answer or automatically mark questions which are similar, I came across a particular interesting kind of problem. And that particular problem is that there are situations where me as an engineer might agree that a particular question was answered correctly by this bot, but at the same time, this bot may actually not be contributing much to the particular discussion and might be regarded as a low value comment. So for example, the most common one that you would see on places like Google Plus is around questions around, well, what advice can you give me for registration? What courses should I take? What advice can you give me for my application? Those 2 questions are really common. And when I built the bot will correctly identify these questions, and to a particular degree will also correctly identify the correct response. And the response will be something along the lines of, well, we cannot answer this question for you here, but we can give advice. And of course, the bot would not be able to give advice. And because of this nature of the bot, I decided that I wouldn't really look into improving the recall rate anymore because, well, that in my opinion would be a low quality sort of response. And there have been some notes written on this from an information retrieval paper that I read, and it was to do with the user perceptions and the system designer notions of quality that I have here. And in this case, I felt that this probably wasn't the best way to proceed. Probably the better way to proceed was, how can we organically grow or mark or detect unseen duplicate questions? And this was a more important part. Unfortunately, I didn't have enough time to explore this, though I do have some ideas of how this could work. For example, what probably spurred me on to do this topic in the first place was one of the papers which was posted on Piazza about the SuperMOOC posters, the super posters. So one way that you could determine what is a relevant question which you could add to the corpus in order to detect other questions which are similar are based on questions and answers which you determine to be high quality. And this quality can be determined by models which try to detect experts within a Piazza community, which can then be used perhaps to detect possible candidates for teaching assistants for that particular course. So in order to build models like that, you would have to consider the poster history and how the poster interacts with the forum. So that would be an interesting next step that someone might want to take with regards to this project. Can we use this model and in conjunction with behavioral aspects of a poster to detect quality experts within these communities and use their answers in order to improve the bots to make the answers more bespoke and hopefully more relevant to the user. And if someone can do that, then I'm pretty confident that we will be able to reduce the clutter in places like Piazza and also Google+. That really is what my whole project was about and what I was trying to achieve. So I hope you enjoyed this presentation. I do encourage you to read the paper, click through the repository, and also provide me with any thoughts that you might have. Thank you again for listening.